Hello, my name is Samantha Ouertani. I work with NOAA's Global Drifter Program at the Atlantic Oceanographic and Meteorological Laboratory. I'm very excited to announce the launch of a new data server where you can access the Global Drifter Program's drifting buoy data. This tutorial video is designed for those looking to access drifter data but have little to no experience using ERDDAP, as well as users who are familiar with ERDDAP but may not be experienced with making advanced queries or using the graphing capabilities. For your convenience, the tutorial is divided into 5 chapters. You can skip ahead to a chapter or go back to a chapter using the timestamps in the description box. To begin, the URL here, erdap.aoml.noaa.gov/gdp/ERDDAP. This will take you to the ERDDAP homepage. And I know this is an intimidating wall of text describing what ERDDAP is and its benefits, but the goal of this video is to alleviate your fear of this wall of text and guide you through the data retrieval and graphing process. In short, ERDDAP is a NOAA-created scientific data server that modernizes access to scientific data sets. With ERDDAP, it's now easier to download scientific data. ERDDAP standardizes download formats and offers many format options for free. The top right of the screen here, highlighted in light blue, shows you the specifics of whose ERDDAP you are looking at. So since this is the Global Drifter Program's ERDDAP, we see a link to the Global Drifter Program here, as well as the general NOAA, AOML, and Physical Oceanography Division links. For ERDDAP servers containing many data sets, the search bar is a convenient way to search for a data set. So we have the search bar here. For example, I could search for drifter, and the data sets corresponding to drifter will pop up. Now let's go back to the home page. And directly under the search bar, we're going to click on View a list of all 3 data sets. Now you should see a table listing all data sets hosted on the Global Drifter Program's ERDDAP. As a brief overview, the Global Drifter Program at AOML, or the Atlantic Oceanographic and Meteorological Laboratory, is responsible for maintaining 2 drifter datasets shown here. I will provide an overview of the datasets, but for more information, please click on the question mark icon here next to the dataset. The first dataset listed here is the 6-hour interpolated quality-controlled drifter dataset. The 6-hour dataset measures sea surface temperature and drifter positions at regular 6-hour intervals, while the hourly dataset records these measurements at regular hourly intervals. And here we have the hourly dataset. Both the 6-hour and hourly datasets are updated every 3 months in what we refer to as delayed mode, during which the Drifter Data Assembly Center applies quality control procedures to interpolate the data, identify accurate start and end times, and remove incorrect measurements. Now let's learn how to retrieve drifter data. In this tutorial, we will work with the 6-hour quality controls interpolated dataset. Please note the procedures discussed in this tutorial are valid across all other drifter datasets. To request data for a particular dataset, click on Data, highlighted here, underneath Table.data, corresponding to the dataset of interest, in our case, the 6-hour interpolated QC drifter dataset. So click Data. This will take you to the Data Access form. Here we see a list of all datasets variables beneath the dataset title and other information describing the dataset. At the top, we have the most relevant drifter variables and measurements. For example, the first variable listed is the drifter's ID number. To find out more information about a variable, simply click on the question mark icon next to the variable name. If I click on the icon for ID, we can see that the string long name tells us the full name is the Global Drifter Program Buoy ID. Other important drifter variables are the WMO number, which is the World Meteorological Organization identification number, time in the Universal Time Zone. Drifter measurements also include latitude, longitude, SST, or sea surface temperature in degrees Celsius, air_SST, or the error in sea surface temperature measurements, VE, or eastward velocity, Vn, or northward velocity. For each variable, ERDDAP provides the minimum and maximum value of the variable in the entire dataset. For some variables, such as VE and Vn, we have large values that look erroneous, but in reality, they are representing not a number value, also seen as NaN for variables such as stroke detect sensor. The rest of the variables below are what we consider metadata, which is information describing the drifters. For example, we have the variable type def. And this code tells us if a drifter is still transmitting data, and if not, why the drifter is no longer active. For example, and you can see in the pop-up box when I click on the information icon, that code 0 means the buoy is still transmitting data, code 1 means the buoy ran aground, and etc. This list of variables can be intimidating at first. And a great way to take a glimpse of the whole data set is to view the data set as an HTML table. So we're going to scroll to the bottom of the variable list. We're going to find file type. We're going to make sure that the default option HTML table is selected. And then we hit the submit button to generate our request. And now we see the same variables displayed on the horizontal axis with all the information below in a large table. Now let's go back to the data access form by clicking your browser's back button. I'm going to start a drifter query, and I want to search for a single drifter. First using the ID number, and then we'll practice using the WMO number. To simplify the data output, let's only select a few number of variables. So we're going to find the uncheck all button, click it. I'm going to select ID, WMO, time, latitude, longitude, and SST. Let's also clear the preset time values here. Search for a singular drifter by ID. We're going to find this little greater than or equal sign and open the drop-down menu. We're going to select the equal sign tilde operator, or the second option from the top. And now we're going to enter the 15-digit ID number in double quotes with no spaces. We're searching for drifter ID 300-234-060-655-120. And we're going to close the double quotes. Please note, most drifter IDs are 15 digits. If you have the full IMEI 15-digit ID, please search by ID number. If not, you can use the conversion file to look up the WMO number. So now we can generate the request by clicking submit. And here we have all the outputs for the corresponding ID number we searched for. Now let's go back again. And instead of searching for ID, so I'm going to clear this and reset the operator, we're going to search by WMO number. So we're going to open the double quotes again, and then we're searching for a 7-digit WMO number, 7100701. Close the double quotes, remember no spaces, and hit submit. Now let's go back again. Now, if we want to search for all drifters that have entered a specific geographic region, we can constrain the latitude and longitude variables. So let's clear our WMO selection. For example, to obtain data for all buoys that have passed between 36 degrees south and 42 degrees south, we're going to use the convention that south is negative. And so for latitude, we want greater than negative 42 degrees south, less than negative 36 degrees south. For longitude values, since we're searching for 19 east, we're going to use positive east values. So we're going to range greater than 19, going until 25 degrees east. Please note that the latitude values shown by the minimum and maximum range between negative 90 and 90 degrees, and the longitude values range from negative 180 to 180 degrees. Now we can click submit at the bottom. And here we have our request generated in an HTML table. And here we see the latitude and longitude. Instead, if you wish to obtain interpolated drifter data for all drifters within a particular time period, we're going to change the time constraints. So let's clear our latitude and longitude constraints. We're going to enter the desired beginning and end dates into the constraints here. For example, to obtain data for all buoys transmitting between January 1st, 2010 and February 14th, 2016, we're going to use the format year, month, day. And since we're interested in data starting 2010, January 1st, so we have year, month, day, and we would like the time period to end 2016, February 14th. And make sure you have the preset operators so you do not need to change anything. Now we have ERDDAP searching for values greater than January 1st, 2010, but less than February 14th of 2016. And remember, there are no double quotes here. Then we can click submit at the bottom, and we have all the data corresponding to the certain time period that we submitted displayed here. Viewing the dataset output in an HTML table is the default option, but it is not the only option. So I went back to our previous query by hitting the back button, and we're going to scroll down as if we're hitting submit. But instead, we're going to find file type, and we're going to open this drop-down menu. For example, let's download the same exact query, first as a CSV file, and we can hit submit. A file will start downloading in your downloads folder rather than in the same tab. Now let's download the same query as a MATLAB file or a .mat file. And again, this download will open in your downloads folder. You can also generate a URL with the selected search parameters, which can then be shared with others or referenced at a later date. I will delve into the specifics of using the URL in the next chapter. Starting again with the data access form for the 6-hour interpolated QC drifter dataset, we're going to learn how to search for multiple drifter IDs now that we've seen a singular drifter ID search. Again, starting out with only several variables checked, I'm going to hit uncheck all. I'm going to select ID, WMO, time, latitude, longitude, and SST. Let's also clear the pre-selected time values. And now to search for multiple drifters using the AML ID number, we're going to find ID variable at the top, open the operator drop-down menu, select the second option from the top, or the equal sign with the tilde. And now we're going to open double quotes. We're going to enter our first drifter ID number, 300-234-060-655-120. And now to add another drifter, even if you want to add 3 drifters, we're going to use a pipe bar to separate. So it looks like that. And we're not going to include any spaces. Now I'm going to enter a second 15-digit ID number. ID number is 300-234-061-474-270. And now we can close our double quotes and scroll down to the bottom to see our results in the same tab. We're going to generate the HTML table request. And now we see one ID number, and if we continue scrolling, we will find the other ID number. So this table only displays measurements from 2 drifter IDs. We can also search for 2 different WMO numbers. So I'm going to clear the ID selection change the operator back. And now the same steps apply. So we open the drop-down menu next to WMO. We select the second option from the top. We open our double quotes, and now we're dealing with 7-digit WMO numbers. So our first number, 7100701. And now to indicate to ERDDAP that we're searching for another drifter, we're going to use a pipe bar to separate the ID numbers. And then I will enter the second one, 5100526. And we close our double quotes. Remember, no spaces. Scroll down to the bottom and we click submit. And now this table, which is much longer than the initial preview, will include data from 2 different WMO numbers. So let's combine what we've learned in the previous chapters and make a query using multiple constraints. For example, to obtain data for all buoys located between 25 north and 26 north, we're going to use positive values. So I'm going to, first of all, clear my previous WMO selection, since we're not going to filter by a WMO. Again, we're searching for buoys located between 25 north and 26 north. And for latitude, the convention north is positive, so greater than 25, less or equal than to 26. We're also interested in buoys that travel between 79 degrees west and 80 degrees west. And west is negative in longitude convention, so we're going to add negative 80 to negative 79. So now this constraint is our geographic area. But what if we also want to search for drifters that traveled in this area between January 1st, 2010 and February 14th, 2016? We can also add that constraint by typing in these dates using the year, month, day format. So these will have no quotes. Our first starting date is 2010, January 1st. And it will span until 2016, February 14th. So now we can scroll down again to the bottom and hit submit. And now this table shows drifters that have passed through a certain geographic area during a certain time period. And let's go back and introduce another feature. So I'm going to leave the same data request, but I'm going to scroll down. And before I hit submit, I'm going to go to server-side functions. And this is just an additional optional feature of ERDDAP that will continue to filter our request. So here we can order our results by variables of our choosing. And please remember that if you don't know what a feature is, you can always click on the question mark icon to find out more information. So server-side functions has 3 different boxes to choose from. I am interested in listing our results in ascending order by first time and second drifter ID. So we're going to select this blank open space and we're going to open the drop-down menu. We're going to select order by, which orders by ascending order. And we're going to choose first, we're going to first choose the time. And then we can add another order by feature and we're going to choose ID. So now we can scroll down. And if you would like to change the file type, of course, you're able to change it here. I will display it as an HTML table. And then I will hit submit. In the HTML table, we see that time is first sorted in ascending order with the initial start date at the top. Since we specified ID as the second order by variable, IDs are also listed in ascending order for the same time entry. For example, we have 2 of the same time entries. Therefore, the IDs are then listed in ascending order for the corresponding time entry. Please note that for large data requests, using the order by feature may result in a request timeout. If you do encounter this, we recommend that you resubmit the request without the order by feature, or you resubmit your request using a smaller subset of data. Using the same data request form, we're going to explore the URL feature in greater detail. So as you can see, we still have the constraints that we used earlier, the time constraints and the geographic region constraints. So we're going to scroll down as if we were going to hit submit, but we're not going to hit submit. And we're going to find the button that says just generate URL. This is right above the submit and right below the file formats. As briefly mentioned in the previous chapter, you can generate a URL to save your search parameters to send to a colleague or to use at a future time. Let's take a closer look at the URL feature. So to ensure that our constraints are saved in the URL, I'm going to hit just generate URL. I'm going to copy the URL. And I'm going to open it in a document so that we can take a closer look. Now, the first part of the URL is simply the GDP ERDDAP URL, and that ends there, along with the table request form. It is then followed by the dataset ID, which in this case is drifter_6hour_QC. That is then followed by the file format specification. In our case, that is HTML table. Now, the rest of the URL is actually our search. So here we have the variables that we've chosen to select in our request. So we can see ID, WMO, time, latitude, longitude, SST, and time. Additionally, with the actual constraints. So here we have our time constraint 2010, January 1st through February 14th, 2016. And then our latitudes ranging from 25 to 26 north, and our longitudes ranging from -80 to -79, or 79 to 80 west. I want to quickly highlight the benefits of using the URL feature. Firstly, the URL is a static link, and this link is functional so long as the data set that is referenced by the URL remains hosted on the particular ERDDAP. Now you can save this URL. I can also open it in a new tab to then bookmark it and create a bookmark if I'd like to reference at a later time. I can directly copy and paste this URL to send into an email. I can save this in my personal notes, etc. And as you just saw, when I click the URL from the Google document, our direct data output is shown. Now, also a really neat feature of the ERDDAP URL is once you've kind of generated the URL a few times and you understand the basic format of the URL, you can make changes to the URL yourself without revisiting the data request form on ERDDAP. Or you can even build your own URL knowing the variables and constraints that you're interested in. So let's say that I'm no longer interested in starting at January 1st, 2010. I can simply start at January 1st, 2012. The same is true if you would like to adjust the longitude and latitude values. And now when I click on this link, ERDDAP will generate my request corresponding to the constraints specified by the URL. And we can see here that now we're starting at 2012 instead of 2010. You can take the URL feature even further. Let's say that you are completing a research study centered over a certain geographic region, the parameters that I have listed here. But now you're not interested in data spanning from January 1st, 2010 until February 14th, 2016. Now you are only interested in all data starting 2010, January 1st. So to reflect this in the URL, I would simply remove the second constraint, and now ERDDAP will search for all data after or greater than or equal to this date. And so if I generate this URL, hit the button, and we're going to copy it. I'm going to paste it into this document again. Now we have a static link that will always fetch the latest data since we didn't specify an end date. If this is the only region of interest for you and time span, you can simply always reference this URL and you don't even need to resubmit your ERDDAP table data request. And now let's go back to our data access form and let's generate a URL for the same data request. As you can see, I have a start time, but no end time. But we're going to generate this request for a .mat file to open up in MATLAB. So we scroll down to file type, we open up the drop-down menu, and we find .mat to download a MATLAB binary file. Now when I generate the URL, and again, I copy it. If I copy and paste this into a new tab, a download will automatically begin. So now that we've selected the .mat file, I'm going to copy this URL and we're going to paste it into the same document to take a closer look. Now that I've copied and pasted the new URL, we can compare, and you can see that the only difference between these two URLs is the file format. So here we were looking at an HTML table earlier, and now that we've generated a .mat file, I can easily change this to a .csv file. And once I copy and paste this into a new tab, a .csv file download starts. You can also view this download in your downloads folder. Downloading your file as a .mat file or, for instance, a JSON file is a great option for programmers. So if you are a programmer, your computer program of choice can also retrieve your data requests by changing the file format from HTML table to a JSON file, a .csv file, or a .mat file. There are many other program-friendly formats. Through ERDDAP's RESTful web service, computer programs can search for the URL and read in the data subset without you as a user having to access the ERDDAP interface. So with more experience, you can also learn how to build this URL yourself, and you can write programming scripts to generate the URL for specific entries. Starting again at the list of datasets, we're now going to learn how to use ERDDAP's graphing feature. There are two different ways to access the graphing page from this list of datasets. The first way is you can click on data like we have been doing before for the dataset that you're interested in. And this is a familiar page, the data access form. But if we look underneath the title, we see a small hyperlink called Make Graph. And if we click on this, this will take us to ERDDAP's graphing page. Now let me show you the second method from the list of all our data sets. Instead of hitting data underneath table DAP data for the corresponding data set, we're going to look to the right and we're going to see graph under make a graph for the corresponding data set. And we hit graph. And lo and behold, there we are at the graphing page once again. So now we see the make a graph page. This is similar to the data request form with the dataset title and relevant information at the top of the page. On the left, we have the graphing variables and constraints, and then we have the graph displayed on the right. So first, let's look at graph type, x-axis, y-axis, and color. Depending on the variable that you want to plot, you can change the data point type from the default markers, which is selected here. Again, please note the question mark icon that you can click on for more information. We can change from markers to, let's say, vectors. And once you change the graph type, ERDDAP graph will automatically reload. Now the vector lines are quite thick, but the marker has been changed. And there's also an option for lines, so no arrowhead. But we're going to stick with the default marker option. The x-axis and y-axis by default are set to longitude and latitude, respectively. Let's leave the x-axis and y-axis set to longitude and latitude so that we can see our results in a map. The last option underneath graph type is color, and the color actually determines the variable that you're interested in plotting. So I think upon generating this page, it defaulted to WMO, which is, again, the World Meteorological Organization ID number. But I'm interested in plotting sea surface temperature. So I'm going to open this drop-down menu, and I'm going to click SST. To see these changes reflected in our map, we're going to scroll down, and here there's no submit button, but there's a big button called redraw the graph, and we hit this to see our new changes. And so now we see a more colorful map, and we can see that sea surface temperature values are plotted with the appropriate color bar and labeling below. Now, similar to the data request form, we can specify variable constraints. For example, to obtain data for all buoys transmitting between January 1st, 2010 and January 2nd of 2010, so we're only going to look at a day of data, we're going to use our year, month format, enter our start date, and then we're going to enter our end date, which is only one day. So this is January 2nd of 2010. And now to view these changes reflected in our graph, we scroll down and we hit redraw the graph. And depending on the amount of data in your query, it will take longer to load. But here we see SST values across the globe for 1 day's worth of drifter data. Now let's go over how to use the geographic area constraints. So I'm going to actually clear the time selection by finding the blank entry at the top of the drop-down menu. And there we go. Now we have a blank slate. So to search for drifters that have entered a specific region, we're going to constrain the latitude and longitude values. So go ahead and select those two. And now let's enter our values. So for latitude, we're interested in looking at buoys that have passed between 36 degrees south and 42 degrees south with the convention that southern latitudes are negative. So we're going to use negative 42 to negative 36. This way, ERDDAP will search for latitudes greater than negative 42, but less than or equal to negative 36. And then we're also interested in looking at longitudes between 19 degrees east and 25 degrees east. And because eastern longitudes are positive, we do not need to add a negative sign. So we're going to go from 19 to 25. And this tells ERDDAP to search for longitudes greater than 19 but less than 25. And again, they are positive, so they reflect eastern longitude values. Please note that before, as I mentioned, with the data request form, we have latitude values ranging from negative 90 to 90 degrees and longitude ranging from negative 180 to 180 degrees. So now we can click redraw the graph at the bottom. And as you can see, there are a lot of drifter measurements here, but the main thing to note is that the longitude and latitude values have changed. And so we can see that on the X and Y axis labeling, and the general size of the graph has also changed. Please note that you can use multiple constraints as we did earlier in the previous chapter. So currently right now, we're only using the geographic constraint, but let's say we're interested in searching and further refining this search, which has many, many observations over the course of the data set's history. So let's constrain this by selecting SST, and we're going to pick a value that makes sense. So from this color bar, we can see that the SST values are ranging from 0 to 32 degrees Celsius. So I'm going to choose 24, and I'm going to display drifters that entered this geographic region but have SST measurements greater than 24 degrees Celsius. So again, just add SST from the drop-down menu, specify your value. You do not need to change any operators or add any quotations. So now we can hit redraw the graph. And now we are looking at many less observations. And now you can see that the SST constraint worked, as we're only looking at these orange values, which corresponds to greater than 24 degrees Celsius. Now we are able to see our graph displayed here, but what if we're interested in working with the data that makes up this graph? Well, ERDDAP has thought of everything. And so if we scroll down, instead of hitting redraw the graph, we see that the file type is set to HTML table. And if we click download the data, the same way that we have been observing outputs in an HTML table, we can see the same for the data used in the graphing feature. And of course, we can change the file format. And so if we're interested in looking at the data in CSV or a .mat file, we can change that and the download will begin in a different window. Now we can also save the graph as a PNG file. We would open the file type drop-down menu. We would scroll down, and where is it? And here we go. And so we can choose PDF or PNG, small PNG, or a larger image, even a transparent image. So if I select .png and I select download the data or an image, then now we have our image in higher resolution to download as a PNG file. We can also plot SST observations for a singular drifter. So let's remove our latitude and longitude constraints, and you can see that the actual entries are also removed. I'm also going to remove SST, and now we're going to add the constraint of ID. So now we're going to search for a singular drifter. I'm going to enter it myself. I'm just going to type it in, but you do have the option to also open this drop-down menu, which contains a list of all the IDs. Now, because our drifter data sets are very, very large, this list is also quite long. So I do not recommend using this list if you're searching for a particular drifter, but if you're interested in just plotting any drifter, you can always open up the drop-down menu and select an ID. In this case, I have an ID in mind that I would like to use. As I said, the drop-down menu does create some lag. And so in this case, we're going to change the operator again to the equal sign with the tilde. We're going to open our double quotes, and we're going to enter a 15-digit IMEI ID number, which is 300-234-060-65-5120. And then we close the double quotes. Now, if we redraw the graph, we can actually see the trajectory of a singular drifter. There are many observations, so the borders of these markers are overlapping, but we can change the graph type from marker to line, and ERDDAP automatically regenerates. We can also change the color. So I'm going to choose pink and redraw the graph. And now we can see a more detailed graph of the trajectory of this drifter. If we want to save our pretty graph, let's go back and review how to download this image. So we're going to open the file type menu, and I would like to download it as a PNG. And then it will open up in the same tab. And I can save this image, I can copy this image, of course, send it anywhere. So let's go back to our graphing page. As described in detail in Chapter 4, if you would like to use more advanced features, such as searching for multiple drifters instead of a singular drifter, you can use the pipe bar. If you're also interested in using the URL feature and perhaps changing your request through editing the URL, you can also do that. Please visit Chapter 4 for a more detailed recap of using the advanced features. With that, the ERDDAP tutorial concludes. We are very excited to launch our Global Drifter program, ERDDAP, and for users to start using our data more accessibly. We've really tried to address all the features that we could think of for new and experienced users, but if you have any questions or concerns at all, please visit our contact page that is displayed on the screen as well as listed in the description box. And if you are using our data, please cite the Global Drifter Program's DOI, which is also displayed on the screen and listed in the description box. Thank you very much.